So we're given this problem here for a gas law, and we need to figure out first which one we're going to use. Ideal gas law, combined gas law. I see moles, and I know the N here stands for moles, so maybe it's the ideal gas law. Do I have an initial and final? No, it doesn't seem I have initial and final. What it seems like is that I have pressure, volume, temperature, and then kind of information for this particular point in time. We're trying to figure out what the volume here is. So we're going to use the ideal gas law. So P, that's our pressure there. V, we're trying to find volume. We don't know what that is. We have moles right here. N, R, that's a constant. We'll look that up. And then T, temperature. We do have a bit of a problem though. The temperature, that needs to be in Kelvin. So we'll need to change that. So when we have pressure in kPa, when you have kPa, you just need to know that you're going to use this value of R here. So if it's kPa, you'll have joules over moles times degree Kelvin. And this -1, we could write this with these here as the denominator since we have the -1 power for each. Let's do that. So this might be easier when we work with the units. So let's put all the values in, but before we do that, we do need to get this to Kelvin. 297.15, that's going to be the degrees in Kelvin. And you see right here, it's got to be in Kelvin or this constant doesn't work. So now we can put everything in the equation. So when we do the math, let's just divide both sides by 98.1 kPa. And if you do all the math, the volume works out to be 50.36, let's call it 50.4, that's our volume, and that'll be in liters. So that's the final answer here. It's a little bit of work. Make sure if you have kPa, this is your value for R, and if you have degrees Celsius, change that over to Kelvin so that works out correctly. It's Dr. B. Thanks for watching.